Hey everybody, this is Mr. Munson. We are getting ready to start actually Unit 7. This says 9. If that says it on your sheet, just go ahead and change that to a 7. This unit actually used to be Unit 9, and so we're going to go ahead and change that. Okay? All right, well, let's go ahead and get started and go through this. Remember, you're placing your words on the back side of the sheet. If you look on the back side of the sheet, it says word and phrase. You're putting it there. Don't forget to cut your tabs so you can fold it back and forth and use them as flashcards, okay? So a side of a triangle that helps, and this is a typo here, helps form one of the angles in a triangle is called an adjacent side. Okay, so let's take a look at that real quick. Let's take a look at this shape over here. First of all, let's just pull this out of the way for a second. So if you take a look at B, and we could do this with any angle. If we're looking at B, B is made up of these two sides that the blue arrows are pointing to. Those are the adjacent sides. They help make up the angle, okay? AC, on the other hand, does not have anything to do with forming the angle B. It actually is opposite it. That's going to be our next word. Now keep in mind, one of the things I look at is you can tell that AB and BC form the angle B is because B is in the name. But look at angle C or side C, AC. AC has nothing to do with B. It's across from it. It has nothing to do with forming it. Let's move on. All right, the next one is the legs of a right triangle, and it's plural. The legs of a right triangle are two legs adjacent to the right angle. So we just talked about what adjacent is. So looking at the right angle, you should recognize that these are the two legs here. Leg 1 and leg 2. It doesn't matter which one is which. Next one, the hypotenuse. Okay, the hypotenuse of a right triangle is the side opposite the right angle. See above, okay? All right, let's keep on moving. Let's see, we got the Pythagorean theorem states that if A, B, and C are sides of a right triangle, so the important thing is they're telling you, hey, you know it's a right triangle, then you can assume that A squared plus B squared equals C squared, right? Okay, so let's just make sure we understand what this says. It says given three sides of a right triangle, right? If that's true, then I can assume A squared plus B squared equals C squared. Not greater than, not less than, but equal to it because I know it's a right triangle and it's the sides of a right triangle. Okay? All right, let's look at the next one. It says the Pythagorean theorem converse. The Pythagorean theorem converse says that suppose I have three sides of a triangle, A, B, and C, and when I plug them into the Pythagorean theorem, then and it works, then it must be a right triangle. Now this is a repeat of stuff that we've already done in the past, so this shouldn't be too new. I want to take just a brief time and show you how when you look at these two statements, the converse, or the Pythagorean theorem and the Pythagorean theorem converse, they just take the first part of the triangle, or the first part of the statement, and they switch the order. So they take the green and they move it, they take it and they bring it over here, right? And then they move it over here for the converse. Just take a look, okay? So we have, hey, look, it is true A squared plus B squared equals C squared. If that's true, then guess what we get to conclude? It's a right triangle, okay? Very good, let's move on. All right, these two triangles that you're just gonna learn to memorize these two triangles, okay? So we have the special triangle for a 30, 60, 90 triangle. And so the sides for them are 1, 2, and square root of 3, okay? You have to remember them. This is how I remember them, 1, 2, square roots of 3. And I just know that from our previous work, if I have given three sides like this, 1, 2, and square root of 3, one of those sides has to be the larger side, and it's going to be across from the larger angle. So, I do some work of organizing this, and I realize that 2 is actually the larger number. When you take the square root of 3, you get 1.7 or 1. I can't remember what it is, but it's a smaller number than 2. Okay, so the square root of 3 actually belongs across from the 60, not on the 90. Okay, so 1, 2, square roots of 3. It just becomes like lyrics to a song. Once you memorize them, then you can do it. The reason we're going to want to know these special triangles is that I'm going to simply give you triangles that you know are 30, 60, 90 triangles, and I'm going to give you one side, 5. And then I'm going to ask you to find the other sides. And you're going to have to bring this triangle into the problem and use unit 6, the one you're just leaving from. You're going to have to use it to write down, define the x and the y using proportions, because these two triangles are similar by AA. Okay, so you're going to memorize this triangle. It's going to be a tool that you're just going to hold in your belt when we come to class. Next one is the 1, 1, or is the 45, 45, 90 triangle. And so if we wanted to look for the hypotenuse of this triangle, okay, so I could take 1, square it, and 1, square it, and give me the hypotenuse squared, because it's a right triangle. Once I square this, I get, 2 equals h squared. Then I would take the square root of both sides, and I get h is equal to square root of 2. Okay, so again, you're going to memorize these sides. So for a 45 triangle, it's 1, 1, square root of 2. Okay, cool. The thing is that both of them have a square root in them. It's just that it's a different number that's in it. Okay, so just keep that in mind. Let's move on. We're going to learn 3 brand new equations. The first one's called sine. And so this symbol, and watch me do it here off to the at the top here. You draw a circle, you come down, and you just kind of put like a loop across the top. Okay, that stands for theta. And basically, that's like the x of the angle, right? World. That if you know how we always use x and y in our equations and stuff. When we're looking for an unknown angle, a lot of times we'll just use that as our holding spot for an unknown. So in this equation, you have 3 unknowns. You have some angle, you have a side which is opposite that angle, and then you have the hypotenuse of the right triangle you're dealing with. Okay, so we're going to obviously be working with this. What I want you to know is that this is an equation that has 2 sides, a left and a right. You don't want to just know this side of it. Okay, that will set you up for failure. So there's 3 unknowns in here. So in like the next couple of equations, that exact same thing. If you know 2 of the unknowns, you can find the missing unknowns. So come to know those terms or these equations on their own. Next one, cosine. Cosine is adjacent over hypotenuse. So you have some angle you're looking at, and it's equal to the ratio of one of the adjacent sides over the hypotenuse. The last one is the tangent equals opposite over hypotenuse. Now here's kind of a cool thing that I want you to know. There's this word that I want you to just come to know, SOHCAHTOA, and I'll make a reference to some Native American girl and all this stuff, a great mathematician, but that's not really true. That's a big false lie. But in any case, the reason I want you to know SOHCAHTOA is if you can kind of keep track of that word, which is easy to do, you find out that SOHCAHTOA stands for sine, which is opposite over hypotenuse, cosine, adjacent over hypotenuse, and then tangent, opposite over hypotenuse. Okay, so if you remember SOHCAHTOA, it'll help you keep in mind how these 2 equations go together. Let's move on. So we have trig functions here, or the inverse trig function. So inverse trig function is, we're going to be given an equation that looks like this, like the sine of A equals 3 over 5, 3 being the opposite side, 5 being the hypotenuse, right? That's what that formula just told us. Now, A is the unknown. That means the angle that's sitting in the right triangle, we don't know. All we know is that this is some right triangle with the side, and we'll put B here, with the side opposite of 3 and the hypotenuse of 5. So the sine of B is equal to, or sine of A, I'm sorry, let me turn that into an A. The sine of A is equal to 3 over 5. Now, we're going to need our trig functions, our inverse trig functions, so that we can get rid of that sine and make it A equals some number. So we can actually find out what that angle is. What we find out is that the opposite of taking the sine of an angle is the inverse sine, which is written with a sign with a little -1. So here's your 3 sets of inverse trig functions. They're simply used in equations to get rid of sine, cosine, or tangent, just like we use square root to get rid of squaring, and to get it so that we have an unknown angle pop out to be equal to some number. You'll totally understand that as we move forward. I'm just laying the groundwork so that you can have your brain processing it before we get there. Next up, the angle of elevation. Okay? The angle of elevation is basically you have some guy standing here and he looks up and he sees an airplane, right? As he looks straight across with the green line, that's kind of him looking out over the horizon, right? Straight forward. If he looks up to the airplane, it creates an angle between now the horizontal line and the view looking up. And that's called the angle of elevation. Now let's take a look at angle of depression. So the angle of depression is, again, let's say I have an airplane and a guy standing there, and the guy in the airplane is looking straight out, right? When he looks down at the guy, he gets an angle of depression, okay? Now here's one of the things I want you to know. The guy in the airplane and the guy on the ground both have an angle of elevation and an angle of depression. Okay, this guy's looking out to the horizon, this guy's looking out to the horizon, and basically they're looking at each other. Do you recognize that we have a pair of parallel lines cut by a transversal, and we're looking at this angle and that angle, and those are called consecutive interior angles. So hopefully from this quick discussion, you now know that these are not the same angle, but they are congruent. All right, that's it. Let's make sure you have those done. Make sure that if you've written your words in to where I wrote them in, you need to erase them and put them on the back side. Okay? If you bring them in with the words there, I'll just know that you either copied it from somebody else and you didn't follow direction. I can't give you full credit for doing it the way that you want to do it. I want you to do it the way I want to do it. When you get your degree in mathematics and you start teaching your own class, you get to do it however you want. Have a great day.